Let's work again with discrete probability distributions. What we have here on our Excel file is nothing else than a probability distribution again that was given by the following data. You can see on column B that we have a set of numbers from cell 3 to cell 59. We have a total of 57 values that they are ranging from value 3 to value 3 to value 8. What I did is that I counted the values 3, there are 13 of them, 5 4s, 9 5s, 11 6s, 8 7s, and 11 8s. I thought of 57 of them. And then I calculated the probability for the specific value to be found in the column B. So we have 0.22 probability. How did I calculate that? 13 threes divided by the total number of values, that is 57. So 0.22, 22.8% for to select a 3 out of these values, 0.0877, so 8.77% to select a 4 out of these values, 15.78, 79 almost percent to select a 5, and so on. Now I added up all these values, the result is 1, and since the result is 1, this means that the probability that I'm working with is a probability distribution. Remember, you should always check to verify that you have the correct probabilities and that the sum of them is 1. Now, I want to further investigate the specific probability distribution, so I want to find the expected value for the given one. I want to find the variance for the given one and the standard deviation. Right here, you can see at this point, and let me just share this with you, right here on this one, you can see that I have the equations, the formulas, that they give me the expected value, the variance, and the standard deviation. You can see the expected value is the sum, this is what the capital sigma represents, for i's from 1 to n of xi times the p of xi. So if you were going to calculate this by hand, let me show you what this would mean. This would mean that I get this is actually, let me do it this way. This is going to be nothing else than the following. The number 3, look above here, right here. The number 3 multiplied it by the corresponding probability, 0.2287, plus the number 4 times the corresponding probability, 0.0877, plus the number 5, that is the value 5 times the probability to get a 5, 0.15789, plus the number 6 times the corresponding probability, 0.19, plus the number 7, I round up the numbers here, 0.14, plus the number 8 times 0.19. This is what I'm doing here. This is what these formulas represent. And after I calculate the expected value, E of x, I can calculate the variance, because the variance requires you to take the square of the difference for each one of the xi's. You are going to subtract from the xi the E of x, whatever the E of x is. You take the square of that and you multiply this by the corresponding probability. So if I want to calculate that, this would be 3 minus the e of x that I don't know yet, square times 0.2287. And I will continue with, again, 4 minus the e of x square times 0.0877, and so on. So this is how I would calculate this by hand, and it would be quite tedious and time consuming. Let me show you here how you do that in Excel. So the first thing is that you need to calculate the e of x, but before we do that, we want to make sure that we know what is the appropriate programming syntax. So for multiplication, I use a star. For exponent, I use the caret 2, what you see right here. Oops, what you see right here. Caret 2, so exponent is 2, and I multiply. And if I want to calculate, because I would like to calculate the square root for the variance, I'm going to use the function sqrt. So let me start here. So I have the xi, I have the pi. What I need is to take the product of those. So xi times pi, this is what I need. So for each one of these columns, I want the product of the values in the cell H11 times I11. And then I scroll down and I calculate each one of those. And right here, I'm going to sum them up. I will take the sum of all of those. And this is going to be the E. This is going to be the expected value. So I can copy that here, so you have it. Oops. Copy. I can always, if you want to copy something and something comes up that you don't like, you can always paste with values only. So in this way, you ensure that you have the correct value. So I'm making this bigger so you can see it clearly. This is my expected value. Okay. So at the next step, what I want is to continue with my variance. Now I have my expected value. So if I go back to my calculations right here, instead of e of x, I would have 5,5087, whatever the expected value was. Same thing here, 5.5, and I would continue and calculate it. So let's see how we do that with Excel. So right here, the next step that I want to do is for every xi, I want to subtract the expected value. So what I want is for every xi, I want to subtract the e. This is what I want to do here. Excellent. How do I do that? The xi's are on this column, and I want to subtract this value. So I need to lock this value when I do it. So this is going to be e, that is 3, minus, I lock this value, so I copy it, right there, is at cell G3, and I lock it. And I do the same for each one of those, right there. I don't add them up, because this is not what I want. I want to do the same thing right here, multiply the xi, subtract the e from the xi for each one of those. And then what I want is to take the value and raise it to the second power. So this is what I have right here. So I'm going to do the same thing for everything in this column and raise it to the second power. So I take the square of negative 2.5, and I do the same for all of those. Okay, so I have now the squares of the differences of each xi with the e. So at the next step, what I want to do is take the products of xi minus e square times the pi, the corresponding pi. So I do that, and let me properly write it. I want to see where are my numbers that I want to multiply. I want to multiply this number with a PI, with a probability of 3, that is y3, because this is my value of xi, the number 3. So I want to multiply the square of the difference times the corresponding probability. So I want to multiply the I11 with the L11. So I do equal the L11, that is the difference, times the I11, that is the probability. And I got it. So that's now the product of all of those. And I have it. So the next step is to sum them up. So I sum all these up. There it is. And that's my variance. This is how I calculate the variance. So I go here, I copy that, I paste with values only, and I beautify my results. There it is. So that's my variance. After I do that, I want to take now the square root of that, and I will do. So this is my variance. Let's call it var here, right? Let's call it this right here x, and I'm going to calculate now the standard deviation. That is nothing else than the square root of the variance. So I write equal SQRT. This is the built-in formula for Excel that calculates the square root of what? Of the previous cell, that is this one. So my standard deviation is this. I write here equal. So, sorry, I copy that and I paste it with values. I beautify this right there, size 16. So I have all three values right here. If you want to fix your table as well, what you want, let's see if it works. You can do that, copy this, because this is what you want, and you want to copy the format, not the values, not the information, but the format. So I'm going to try to do it like this so you can see it. So I am going to format. The format is right here. You see that it says formatting. You click on the formatting and easily you have your results for everything. Make this also in pink, and these are my variance and my standard deviation, and this is the final. And in this way I calculate easily the variance, the standard deviation, and the expected value of a random discrete variable.